Hello everyone, welcome to Industrial Instrumentation 2 and myself D. Devasugamani, Assistant Professor, Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to discuss differential pressure flow meters, and these are the contents which we are going to discuss now. Type of flow meters, differential pressure flow meters, construction, working and applications of orifice, Venturi and flow nozzle, and some industrial flow meter illustrations and comparison. First of all, we must know why we measure flow. In general, flow measurement is one of the critical parameters in many industries, especially for process control industry. In many processes, it is essential to know the right fluid in right time at right place, and to know the volume of liquid, and for construction purpose and for laboratory purpose. For these, we use more number of flow meters in industries. Of course, these are the commonly used flow meters that are used in industries. Here, we will focus on differential pressure flow meters. Differential pressure flow meters are most common flow meters which are used in all industries to measure the volume of flow in gas, liquids and steam. It follows the standards of ISO and ISA. It consists of laminar plates, orifice and nozzle and venturi in order to create the artificial constriction among the pipe. It creates a pressure difference. When the flow rate increases, more pressure drop occurs, and all has been related with the help of Bernoulli's equation, by which the pressure difference is related with the flow measurement, flow rate measurement. And this is how the differential pressure flow meter works. It consists of artificial constriction, and the static pressure between upstream and downstream of this constriction is used to determine the flow rate. By Bernoulli's equation, the differential pressure is directly proportional to square of the mass flow rate. That is, del P is directly proportional to QM square. In order to remove the square root, we use the square root extractor so that we can get the flow rate directly. And these are the types of differential pressure flow meters: orifice meter, Venturi as well as nozzle. And first one is orifice meter. Orifice meter have become more popular in industries because of their easy to use and control. It consists of orifice plate, sensor and transmitter. And the orifice plate is used to create the pressure difference among the pipe based on the fluid flow. And it's based on Bernoulli's theorem, which relates the pressure difference with the flow rate. And it consists of inlet section, orifice plate, flow conditioner as well as outlet section. Of course, the orifice plate mainly used to create the pressure difference among the pipe in order to measure the flow rate. And the pressure drop is sensed by the differential pressure sensor. Of course, mainly a diaphragm is used. That pressure difference is carefully represented, noted by the pressure gauge. And it's been used to measure the flow rate when it's calibrated with the help of Bernoulli's equation. And the flow rate is given by Q is equal to CD A0 into A1 square root of 2GH by square root of A1 square minus A0 square, where CD is nothing but discharge coefficient or coefficient of discharge, which is the indication of pressure loss in the piping. And orifice plates. Orifice plate is the heart of the instrument. It consists of a number of slots, and it's been mainly used to create the pressure difference across the piping. And the various types of orifice are concentric orifice, eccentric as well as segmental orifice. And the diameter of orifice is 0.5 times the diameter of pipe. And for eccentric used for pure fluids, and segmental used for solids as well as mixed fluids. And these are the position of taps. Taps are mainly used to measure the pressure difference across the flow. It's designed based on the beta ratio. And the common tappings are corner taps, flange taps, as well as ring, as well as vena contractor taps. And the advantage of orifice meters are cheap and very easy to install. It can be used to measure large pipelines. And the disadvantages are orifice meter have low discharge coefficient and poor recovery factor, which gives inaccuracy. And orifice meters mainly used for the measurement of flow rate of pure fluids and solids as well as steam applications. Next one is Venturi meter. Venturi meters also become more popular in industries like orifice. It's mainly used to measure the velocity of flow of pipe. And when compared to orifice, Venturi has long pipe. It can fit for any pipe size in a normal pipeline, and it has no restriction. And the pressure difference is created with the help of design itself by the throat. And of course, this also has been used with the Bernoulli's equation, where the flow rate is measured with the help of a pressure difference. And this is Venturi effect. Venturi effect has been popularly used in many fluid applications. Here, when the flow is passed in a narrow passage, it creates a pressure difference. That is high pressure when the pressure increases with low speed. That is high pressure with low speed and low pressure with the high speed. So this is what exactly used in Venturi meters. And Venturi meter have consist of three sections. That is the convergent section, throat section, as well as divergent section. Each has been changed with the help of some angle. The pressure, the differential pressure sensor has been located in between the convergent as well as throat section in order to measure the pressure difference across the piping. And this is the working. When the fluid enters into the Venturi meter, the pressure keep on reducing, which attains minimum value of P2. And if it enters into throat, again its pressure got increased. The pressure difference occurred between the convergent as well as throat section has been carefully represented and noted with the help of a mercury column of U-tube manometer. This is the height. The height represents the difference between convergent as well as throat section of pipe, which is used to determine the flow rate with the help of the Bernoulli's equation. And this is how the Venturi meter works. And here the air speed is nothing but the fluid speed. And just visualize the speed. Now the speed is low, which means pressure is high in the convergent section and pressure is low in the throat section. So this is convergent section, this is throttle section, and this is what a divergent section. And just see the column of liquid. So all are somewhat similar, equal with the height of the column because of the fluid speed is low. If fluid speed is increased, see the changes. The column of throttle has been increased. The mercury column of throttle has been increased from side. You just compare the flow difference between the convergent column as well as throat column. We get the difference between the height, which are used to measure the flow rate with the help of the Bernoulli's equation. And these are types of Venturi tubes, eccentric as well as rectangular type. Eccentrics mainly used for the measurement of high velocity applications. Rectangular mainly used for solid applications. So these are some exact illustrations of Venturi meters used in industries. And advantages, when compared to orifice, Venturi has a high coefficient of discharge, high accuracy. It can be fit for any pipe size and high pressure drop, high pressure recovery. And the disadvantages are it's expensive and it needs some maintenance. And Venturi meters have been used in many applications like aircraft applications. It's used in automobiles, biomedical equipments, and it's mainly used for all chemical industries in order to measure the flow rate. And third one is flow nozzle. Flow nozzle is a modified version of Venturi. When compared to other elements, flow nozzle have high accurate than others. It has a smooth elliptical inlet with sharp outlet, which creates high accurate than others. And the pressure recovery is far better than orifice, which gives highly accurate of flow. And this is what the exact illustration of flow nozzle, where we can measure the flow rate. And these two are tappings of flow nozzle, which are mainly used to measure the differential pressure. The pressure difference occurred between inflow as well as outflow of the flow nozzle has been used to determine the flow rate with the help of Bernoulli's equation. And these are the nozzle tappings, corner tap, flange tap, as well as D and D by 2 tappings. And advantages, flow nozzle very high accurate and high quality and high coefficient of discharge value when compared to other devices. And applications mainly used for high pressure as well as high steam applications. And this is all how differential pressure flow meter works. Just see the visualization. This is it consists of all three, orifice, Venturi, as well as flow nozzle. Of course, this is an orifice plate and it's been visualized now. And it's a circular orifice plate, and these two are the pressure tappings in order to measure the pressure difference across the piping. And this is called a circular diaphragm. See here, the diaphragm can act as a pressure sensor here. So this is circular diaphragm. When force increases, the area of a diaphragm has been changed. Everything has been sensed with the help of the diaphragm sensor. And this is the visualization of flow. First of all, we look out of orifice plate, and this is flow visualization. So just see that. So this is now the flow is in normal speed. A normal flow rate has been taken out. This is how the flow has been visualized. When pressure is increased, when the flow is increased, it has more pressure created on diaphragm, which exactly the represented with the help of the diaphragm sensor. See the color changed because the pressure has increased, because the flow is increased, which directly affects the pressure. Just see the flow of flow rate. See, the visualization has been clearly pointed out. Now the flow rate is increased with the orifice plate. And when flow increases, more pressure drop occurs. So everything has been carefully noted down with the help of the pressure sensor. And now the flow is somewhat reduced, little bit reduced, which is a slower flow rate. And if flow reduced and the pressure also getting reduced, so both are equally operated. And this is how flow is visualized by through the orifice meter. So, and this visual can indicate the flow rate, and this is nothing but the backflow, how it's been occurred. And this is the nozzle. So this is the flow visualization in nozzles, how it's been visualized in nozzles. Nozzles have a very small pipe when compared to other devices. And when you expand the nozzle, we can get the Venturi meter. Just you look at it. So this is a Venturi meter. So Venturi meter is slightly long pipe when compared to other meters. Just see the visualization of flow in a Venturi meters, how the flow has been varied in Venturi. And Venturi is comparatively long pipe when others. And this is how the exact illustration of working of orifice, Venturi as well as flow meters. And of course, it's a compact unit which consists of flow transmitters, sensors as well as devices. Everything is in compact unit. So we can get the everything direction of all meters in a single line. And this is what the instrument. And flow rate has been directly indicated with this display itself. And finally, we have a comparison between these three meters. Orifice has smaller size when compared to Venturi and nozzle, high head loss, low discharge coefficient, and Venturi and flow are high accuracy than others. These are the references. Thank you.